So far, I have shown you how these powerful tools we have built allow you to create really complex solutions. And many of our partners are making great inroads into video intelligence at the edge with them. But is this enough? Is this enough to address the billion devices and create over 100,000 applications that we envision in the future? To understand the answer to that question, we have to look at the end-to-end lifecycle for these devices. This lifecycle frequently starts with a first creation or selection of a device and a model that runs with that device. This is frequently a very bespoke operation, specific silicon and hardware with a specific model for a specific solution. Once these device and model have been created, they have to be deployed at scale. And this deployment at scale frequently requires experts to configure the devices, to deploy the models, and make sure that they are running properly. Once the devices are frequently deployed in a pilot scale, then you end up doing a validation of those models and figuring out if you have a model fit. These proof of concepts are the ones that consume a lot of time as we perfect the models and as the models get ready for deployment at scale. Once the proof of concepts have finished, we have deployment at scale happening. And that deployment at scale is elusive. A lot of the customers that start this journey never get to this stage because there are so many more challenges in terms of managing the end-to-end life cycle, the hundreds of devices out there. How do you update them completely unrelated to the AI portions? And then the specificities of making sure that the AI models remain stable over time. Once your deployment at the scale is running, you get to actually manage and improve both the model and the devices. And that frequently requires a retrain and model pipeline as well as an improvement process for that device. This life cycle is by no means for the faint of heart. It requires a lot of effort and it has a lot of bespoke portions to it. So the question is, can we improve it? And we went about answering this question by speaking to our customers, and we spoke to over 500 of those customers. And what we heard from them shocked us. 100% of our customers were having problems finding the blueprints to be able to build these solutions. 90% of them were having issues with this matchmaking of a particular component with a particular model, particular accelerator, and then maintaining it. 75% of them were concerned about security, both for the models and the data that they were creating. And 70% of them were ready to use Azure services if only they could get these devices figured out. So we set out on a journey to simplify edge and AI from silicon to service. And we call that solution Azure Percept. Azure Percept is a combination of hardware developer kits and end-to-end AI lifecycle that are born with security in mind from the beginning. Azure Percept bridges physical interactions with the cloud for real-time decision making. And it does that with three pillars. A hardware reference design and dev kits that our hardware partners are using to create devices that will be able to run all the Azure Percept solutions that get created. An end-to-end AI lifecycle management and creation pipeline to create the models that will be running on these devices, managing both the models and the devices on the process. And on this platform, a compelling third-party edge device ecosystem program, not only for hardware manufacturers, but also for software developers, creating applications that will be certified to run on this vast number of devices. We started this journey with the launch of a developer kit. The developer kit addresses vision and audio challenges at the edge by allowing you to create models that can be easily deployed and managed from the cloud or the edge. If we look at this module in the context of video analytics, we can see that it comes with its own carrier host port and a hardware root of trust that is used to authenticate the device itself to the cloud. and attest its state. In addition, it actually brings a hardware accelerator that is attested to the device itself and to the cloud to ensure the authenticity of the components and the security of the models as they're being transported and stored. So let's look at how that Azure Percept payload is implemented. If you remember, we had this vertical stack as the basis of how we are building innovation for the edge, all the way from silicon to software as a service. We implement this in Azure Percept on top of the Azure Percept device by leveraging a particular set of hardware components, a root of trust and a hardware accelerator to provide both identity to the device and performance guarantees for the models that are going to be running on top of them. We run a minor Linux operating system on top of it that, paired with our extensions, it's able to attest the state of the system as a whole to the cloud. On top of this, we're able to deliver a common platform for runtime, and that is the Azure IoT Edge Runtime Platform that connects the device to the hub on the cloud. This allows for management not only of the payloads running on top of the device, but also updates of the internal components of it. Azure IoT Hub also serves as a bridge to enable the device to access Azure services and Azure Percept services. All of these are being exposed through a common interface that we call the Azure Percept Studio. All of these components are present so that we can deliver the Azure Percept solution, which is a combination of an Azure Percept payload and the Azure workloads that are paired with that payload in order to deliver the full end-to-end solution. You can decide to just run the payload locally, or you could decide to run only the workloads on the cloud, or you can decide to run them both, cloud and edge, intelligent cloud and intelligent edge. This is your choice. As we look deeper into this platform, we can look into the Azure Percept payload itself. And you will notice in the Azure Percept payload that we actually have incorporated a pipeline manager. You saw what LVA can do, and it happens to be the pipeline manager for video. We have a trusted AI inference engine, like the component that you saw in terms of the extension for LVA that allows for inferencing, and also any application business logic that you require, as well as Azure Percept libraries that allow us to protect the payloads that are being run on the device, as well as the models. This platform as a whole can run physical device or in a virtual device. And in the case of a virtual device, we will be providing almost all of the same functionality, except that we will take a dependency on the host to deliver the hardware root of trust and hardware accelerator in a way similar to what you saw on a Windows IoT and eFlow. This payload is created by leveraging either Advanced Developer Experience solution or Azure Percept Studio. So let's have a look at Azure Percept Studio and what it can do. The Azure Percept Studio experience is in itself our cloud experience. It provides you with delightful onboarding experience. It gives you a no-code and low-code flow for the creation of models, and it helps you accelerate your journey towards prototypes. But the best way to understand it is to see it in action. So let's have a look at a demo. In this Azure Percept Studio demo, we're going to be setting up a new device. We're going to be updating the models inside of it, and we're actually going to be retraining it. Through this, I hope to walk you through that end-to-end life cycle in only 7 minutes. Let's have a look. So the demo starts with the provisioning of a device. As you can see, I'm going to be connecting to a Wi-Fi network here. Once you have detected the Wi-Fi network, you can choose to connect to it and create a username and password. I'm going to skip this step. And then you can connect that device to the cloud. As you connect the device to the cloud, you're going to be leveraging the connection string that was generated by the platform. And that connection string is going to allow you to authenticate with Azure. Once you have authenticated with Azure, you can come back to the device and the device will finish its installation. At that point, you get to choose what IoT hub do you want to attach the device to. You get to name your device, and your setup is complete. Now, in this case, I have finished setting up one device already, so I'm going to connect to that device. This is opening directly the Azure Percept Studio. As you can see, I have the ability to look at devices, focus on vision or speech. So let's go and look at the devices that I have. This is the device I just provisioned, the NVIDIA Santa Cruz Demo 1. And when I look into that device, I can see that there's a lot that I can do with it, including looking at the video stream that's being generated. Once you do this, you can look at that video stream, and we have a default model that is running on this device. Now, for this example, I'm going to be looking at videos of a street. As you can see, there are some components that are being identified. There's some bicycles and cars, but we can make this better. So let's actually deploy a new model here. We have a set of models, and we can do a general object detection model that will be deployed directly on the device. Notice how that translated into a deployment that is now available through the stream. I can now choose to go and view that stream, and we are now seeing way more components on top of that device. We're seeing people, car, and traffic lights. But frequently, you're going to want to see more than just that. So how do you improve that model? You can capture images, and here we're selecting a new project to detect trees, and we're going to capture frames automatically every 5 seconds up to 5 frames. And this automatic capture will allow me to collect the information that I need to create the model and make it better. We're solving with this a big challenge on getting additional data. Once the automatic capture has been set, we can actually refer directly to custom vision.ai where the training is happening. And we can go and refresh this, and you'll see that once the refresh has taken place, we actually have several untagged images that I can address. So these untagged images are the ones where I get to train a new model. I'm gonna go ahead and start labeling my images and name this tree, select this other component that is also a tree, and this one here. I'm basically labeling the images that are gonna be used now to create the new model. Now I could do this myself, or I could actually ask for suggestions. And you will notice that the suggestions actually are giving me already valid suggestions for components. Now this is using some images that I have labeled before, but based on that, it's already easing my task of creating additional data and labeling it. So I'm gonna continue processing this. There's one more tree that I missed there. Notice that as I go through this process, I'm just labeling all of these images and creating a new data set. This is going to be trained on the cloud, and then I can deploy it and continue to improve the model. And as I label more and more images, that automatic suggestion of objects will continue to provide me with even better suggestions for components to label. So I'm going to be labeling this one as well. I gotta finish labeling all of these images, and once I'm done, I'm missing one more here at the end. Once I'm done with this, I will be able to run the training. So let me just finish this on its own. Now I actually have better recommendations. So this task is gonna take only a few more seconds. Bear with me as we finish the labeling. So once the labeling is done, I get to close this and I can train my model. So I'm gonna go and train this model. I can do a quick training or an advanced training. Now I'm gonna accelerate the training here for the sake of expediency. It took a few minutes, and you see it's not a perfect model, but it's close enough. So let's go and try it. I go back to Azure Percept Studio, and now I can deploy a project. I'm gonna go and select in that project the tree detector that I just created. I'm gonna see the different iterations for training, select the last one, deploy the model, and the model deployment is taking place. At this point, a brand new model is being downloaded into that device. And you know what's happening in the backend here because it's very similar to what we have done in the deployment of other containers. You can see now that in my web stream, I'm loading that model. So when that model is fully loaded, I start to see trees. So there you go. It's not perfect, but I've only captured a few images. You can imagine how this can be applied to conveyor belts, production lines, any and all video inferencing solutions. Now, this is of course a low code and no code solution. It can always be improved with the advanced experience if you want to do that, but this will enable prototyping at scale significantly faster. In summary, Azure Percept builds on top of the powerful tools that I described today in order to lower the time to develop, accelerate the time to ship, and reduce the complexity to operate these systems. With it, we hope to have simplified the journey from silicon to service. And we invite you to join us and the different companies building this product with us to build an entire ecosystem and accelerate AI development for video at the edge. Please join us by visiting these websites and ordering your own dev kit. And I'm looking forward to your feedback and your questions in the chat room. Thank you.